Hey y'all, today's lesson is surface area of cylinders. And what you're going to need is your Volume 2 textbook, pages 521 and 522 and 523. So at the top of page 521, it says surface area of cylinders. And it goes through kind of a real world example of baking a cake. But go to the next page, and at the top is the key concept, and it gives you the formula. And I'm going to explain the formula, and I'm going to break down the formula. But what I like is this picture right here. And again, you maybe have done surface area of cylinders using nets. Sorry, ooh, I need some water. But in 8th grade, we really focus on the formula. But I want you to see a cylinder is formed by two circles, one on the top and one on the bottom. Those are the bases. And then the middle part that wraps around, if you were to unfold it, it is a rectangle. And so I think this picture right here does a really good job of showing you how the net of a cylinder is a rectangle and two circles. And so we're going to be using that part. The blue rectangle that you see, the circles are kind of like a yellowish color, but the blue rectangle is the lateral area. That's the middle part. And then the bases are the circles on the top and bottom. So you see the two bases. And then it'll show you the formula, but I'm going to explain the formula. So the lateral area is this part right here, the rectangle. And then the two bases are the top circle and then the bottom circle. So when we do an example, if we're talking about total surface area, we're talking about all of it. If we're only talking about lateral area, then we're just talking about this middle part right here. And in cylinders, you're going to have a few examples where it's only asking you for the lateral area. So the next page 523, they've done an example for you, and I'm not going to go over that one, but we're going to focus on these two got it questions. And I'm going to work through these examples with you. And I got to cut it out. Okay. So I've got my pencil. Whoops. Okay. Determine the surface area of each cylinder, round to the nearest tenth. So we have, and it's just asking for surface area. It's not asking for lateral and total. So surface area is the lateral area plus two of the bases. And I'm starting the same way that I've started before. Lateral area is that middle rectangle. And the way I'm just going to draw the net up here. So if you have a rectangle and then you have, your bases, the area of this rectangle, well, here's the height, and the area of a rectangle would be length times width, or, height. But this line is called the circumference because that circle will rotate one time around, or this rectangle would fold around this circle. And so that is going to be 2 pi r. And then same thing down here, 2 pi r, because it would wrap around this one circle. So the lateral area, instead of being length times width, it is 2 pi r. And then the width now is h, because we're talking about a cylinder that's standing up, not like a flat rectangle. So the lateral area is 2 pi rh plus the 2 comes from here, 2, and then the base area. So the base area of a cylinder, and I'm shading it in, is the circle, the base area. And again, the area of a circle is pi r squared. So we have 2 of those because we have a bottom and a top. This cylinder is drawn sideways, but you still have 2 bases, and then you have your lateral area in the middle. So LA, 2 pi RH plus 2B, 2 pi r squared. And it's kind of funny because they both start with 2 pi r, 2 pi r. Then you just have to remember which one is the lateral area, is the height, and then the bases are the squared. So today I'm going to use my pi key. The radius is 3. The height of the cylinder is 9. Because remember, the height is going to be if it was standing on its base. If it was, ooh, that's a terrible drawing. It would be 9 feet. And plus 2 pi. And then again, the radius is 3, so 3 squared. Now, because it's asking for total surface area, you can just type all that in your calculator. So I'm going to show you what it looks like in mine. 2 pi times 3 times 9 plus 2 pi times 3 squared. Okay. So I'm showing you what it looks like in my calendar. In my calculator. And the directions say round to nearest tenth. So when I press enter, I am going to come over here and I'm going to add 226.19. So 0.2, because 19 would round up to 2, of feet squared. And this is surface area, so it's squared, not volume. So let me show you another example. B, LA plus 2B. It's drawn where it's sitting on its base, but it gave us the diameter. And so we need to find the radius. So we need to find half of the diameter. The lateral area is 2 pi RH plus 2 pi r squared. And these are the two bases. 2 pi, the radius is 7, and the height is 10. See, here's the height. Plus 2 pi, and then the radius is 7 squared. So once you get all your numbers in, then you can just type it into your calculator. And 2 pi r h, 7 times 10, plus 2 pi 7 squared. All right, so that's what my calculator looks like. 2 pi times r times h plus 2 pi r squared. I'm going to press enter, and I'm going to round to my nearest tenth. So where's my answer? 747 point, my calculator says 699, so rounding up to the nearest tenth would be 0.7 centimeters squared. So those were two quick examples on the surface area of a cylinder, and the formula that I gave you represents the lateral area plus two bases. So the lateral area plus two bases. Okay, I'm gonna save that. All right, and now we have a real world problem for you, and it's worked out for you. This one talks about a circular fence. And so what it's going around, or what that, you can read that one on your own. I'm not going to take the time to read it to you right now. But if you are building a fence, or if you've ever built a fence, or if you've just seen a fence, then hopefully you understand that a fence is going to only be the lateral area. You don't build, when you build a fence, you don't put wood on the top or wood on the bottom. The fence just goes around, which would be the lateral area. And so that's what I was saying, like with cylinder, they actually do ask you just for lateral area. So example C, determine the area of a label. So I really want you to highlight or underline the word label. When you have a label around a can, that's only the paper that goes around the middle. The label doesn't go on the top and the bottom. So we only need lateral area for C. Determine the area of a label of a can of tuna with a radius. So we have a radius of 5.1 and a height of 2.9, round to nearest tenth. All right, so I'm going to come down here, C. So we only need lateral area, which is 2 pi RH. That's the only part we need for the label. 2 pi R is 5.1, and then the height is 2.9. So you can use parentheses if you'd rather because of the decimals. But again, we're only using the lateral area because we only want the label around there. So I'm going to type that into my calculator. 2 pi times 5.1 times 2.9. And round to nearest tenth. So my calculator says, I hope you are typing this into and not just, okay, where's my thing? Here it is. 92.9 centimeters squared. Oops, I could put this up here. 92.9 centimeters squared. Uh-oh. Sorry, y'all. That is just the lateral area. That's how many square centimeters of paper we need to make a label for that tuna can. Letter D says determine the total surface area. So again, we have total surface area of a cylindrical candle with a diameter of 4. So if it has a diameter of 4, that means the radius is 2 and a height of 2.4, round to nearest tenth. So surface area is the lateral area plus 2 of the bases. Lateral area is 2 pi RH plus 2 pi r squared. And I'm going to write that every time, and I'm going to encourage you to write it. Now we just fill our numbers in. 2 pi, the radius is 2, and the height is 2.5, plus 2 pi, and then the radius is 2, so 2 squared. I mean, you could just type in 4, because 2 squared is 4. Now I'm going to type that into my calculator. 2 pi times 2 times 2.5 plus 2 pi times 2 squared. I'm going to show you what it looks like in my calculator. Then I'm going to press enter, and I'm going to round to nearest tenth, and I get 56. So the total surface area is 56.54, so 56.5 inches squared. That candle, that cylindrical candle, has a surface area of 56.5 squared inches. Okay, so those are the examples I have for you, and then we're going to practice some classwork later next time we're in class. But the big thing to remember with cylinders is whether they're asking for the lateral area, which only goes around the middle, so like a fence or a label, and then the total surface area, which includes those two bases. All right, see you soon.